Okay, so today we are going to go ahead and start our unit on rotation. So we're going to be looking at how we can predict the motion of a rotating system and what is the difference between rotation and rolling, because there is a slight difference. So this is where we're going today. So of course, we have our goals by the end of the unit, what we would really like to know. And then, of course, there's some common misconceptions. So, first thing we really need to look at is what do some of the units mean? So, in pre-calculus, or in geometry, you've probably learned that there are 360 degrees in a circle. Well, when we look at a different unit of measurement, that is 2 pi, what we call radians. Now, in another system, that would be the same as 1 revolution. So, you've probably heard of revolutions. Basically, tire goes around once. That's 1 revolution. You've heard of degrees. The radians, maybe not. So what exactly is a radian? So if I take a circle and I take the radius of that circle, and I say, you know what, I'm going to lay that radius out flat along the edge of the circle. The angle that it makes so that this arc length is 1 radius is what we call 1 radian or 1 rad. So we have that conversion to keep in mind here. Now, some of these, as we go through this, we have 4,000. That's revolutions per minute. And we want to convert that to radians per second. So 1 revolution is 2 pi radians. 1 minute is 60 seconds. So we could simplify our units. Minutes. We multiply the top. So we're going to get 8,000 pi over 60. And that's going to be radians per second. We put that in our random number generator. We're going to get 418.87. So right there, that is going to be our connection. So go ahead and convert all of the rest of these. Go ahead and convert those to radians per second and see if they work out. And if radians per second doesn't match, go ahead and try that radians per day and see if that works. So pause the video and start there. Okay, hopefully you've had a little bit of time practicing that conversion. We're going to do some conversions down here. So here we have a tire rotating with an angular speed of 10 radians per second, and we want to know what is the velocity that the car is traveling with. Well, really before we can get into what is the velocity, we need to look at that connection. Now, when I did that radius and what a radian really is, what we found was that the arc length is going to equal the radius times the angle in radians. So if you think about it, your circumference is 2 pi times r. That is 1 distance around the circle. The angle it is covering is 2 pi. So that works. Now, similarly, if you think about it, our velocity, our average velocity, is the change in your distance, in this case arc length, over the change in time. So what we see is that the velocity is going to be r, and our angular velocity is going to be the change in the angular distance over the change in time. So this is going to be omega. Similarly, our average acceleration, alpha, is going to equal the change in the angular velocity over the change in time. So what we get is that the tangential or linear acceleration is equal to r times alpha. So these three equations are what really connects the linear world and the rotational world. So here we have an angular speed in radians per second. We have a radius and we want to know the velocity. So we're going to use v equals r omega. So our radius is 0.3 meters. Our omega is 10, and that's radians per second. Radians are kind of like the magical, mysterious, disappearing units. They tend to just go away. So we're going to be left with 3 meters per second. Now we want to know what is that in miles per hour. Now we could do some fancy conversions in our calculator, but let's just do it this good old-fashioned way. We've got 3 meters in 1 second. Now, if we look at this, 1 mile is 1,609 meters. 3,600 seconds is 1 hour. So that means if we look at our unit analysis, the meters and the seconds are going to cancel. It's going to leave us with miles per hour. So I've got 3 times 3,600 divided by 1,609. And that is going to give us a velocity of 6.71 miles per hour. So mph, or miles per hour written out. So if we have a bug on a turntable and it travels with an angular speed of 26 rotations per minute, we want to know the bug's speed when it is 10 centimeters from the center. So this equation does not work for rotations per minute. We need to convert to radians per second. So we're going to take 26 rotations, 1 minute. So 1 rotation is 2 pi radians. 1 minute is 60 seconds. Eraser got a little big there. We're going to simplify our units, do a little unit cancellation here. So we're going to get 26 times 2 pi divided by 60. And so that's going to give us 2.72 radians per second. So once we know our angular velocity, that's a lowercase omega, it looks like a script W, yes. We want to know the speed, v equals r omega, so that's going to be 0.1 times 2.72, so that's going to be 0.27 meters per second. Now, we want to know the centripetal acceleration. So the centripetal acceleration, remember, is v squared over r. I could get a little fancy and say, okay, well, if my centripetal acceleration is v squared over r, and I could also call that my radial acceleration, but humor me. If v is r omega, I've got that squared over r. So that's going to be r squared omega squared over r. So that's going to be r omega squared. So that's how we can find the centripetal or the radial acceleration using rotational information, just FYI. But let's go down here. We just found v, so we're going to square it. We're going to divide it by that 0.1, so I've got 0.27 squared over 0.1. So that is going to give me 0.74 meters per second squared. Okay, so in order to truly kind of understand what the rotational world is like, right here is a simulation for rotational motion. And I want you to go to that site and I want you to spend some time playing with this simulation, seeing how the ladybug behaves, seeing what the vectors look like on the ladybug. And then we're going to come back and we're going to look at these rotational dynamics and how the linear and the angular connect together.